So this video is going to go through some examples now of exam style circle theorem questions. So just a reminder, these are the theorems that you should have watched in Circle Theorems 1 video. So remember, the angle at the circumference in a semicircle is 90 degrees. So the trick with that one is as soon as you see that diameter, the angle opposite is going to be 90 degrees. This one, the angle at the centre, remember, is double the one at the circumference. This one, the one that looks like mountains, angles at the circumference in the same segment are equal. So basically these angles are going to be the same. And the next one we had the opposite angles in a cyclic quadrilateral add up to 180. And remember, we said to watch out for all 4 points need to go on the circumference. This one is the hardest to spot in an exam. It just is for some reason. So whenever you've got a tangent and a chord, the angle between them is the same as the one as when you join up the ends of the chord, so it will be the same as this one. And then the radius and the tangent meet at 90 degrees. So let's give this a go with some examples that I've got from previous exam questions from different years. So I'm just going to zoom in a little bit for you. Hopefully you can see that a bit better. If you can't see that, this angle here says 54 and this one here says 28. So the first thing that we need to do is to find the size of angle ACD. So one thing just to point out with this, I'm not sure it's going to affect this question, but you can see here you've got a crossover point. It's not the centre of the circle because it hasn't been marked on with an O, so it's not the centre, so just something to bear in mind. So we know that this is not an isosceles triangle because that's not a radius and that's not a radius, so just be really careful of things like that. But however, it is a normal triangle, isn't it? So you could use the fact potentially that these angles are going to add up to 180 degrees. But let's have a look. We're trying to find ACD. So remember to go with the middle letter and join it up. So the middle letter is C. So think about joining it up to A and D. So that joining it up to A would be this line, joining it up to D would be this line. So it's the angle between them that we are trying to find. Now, straight away, I can see these look like mountains. So therefore, it's just going to be 54 degrees, the same as the one at B. So, like I said, I should have put that in there. Look. Give a reason for your answer. So, like I said, this comes up a lot where you have to give your reasons. So we can't just say they look like mountains. Unfortunately, you're going to have to learn those theorems. So the reason is angles at the circumference in the same segment are equal. Okay, so it's really worth learning those. I know it can make a difference of maybe just 1 or 2 marks, but at the end of the day that could be the difference between a grade 4 or a grade 3, or likewise a 7 or a 6, depending on what you're aiming for. So every mark does make a difference. Right, the next one, so straight away, before I even look at this, I'm just going to point out a few things. So you can see here that you've got the arrow shape like this. So I know that this one here is going to be double this one here. The centre has been marked on, so there's no triangles, but you could potentially make a triangle there. Just saying, that might help. I don't know if it is going to help, but that's what you could do. Also, we've got 1, 2, 3, 4. We've got a cyclic quadrilateral, so we need to bear in mind the opposite angles. For example, these two would add up to 180, and also all of that and all of that would add up to 180. So it's just pointing out things to look out for in these circle theorem questions. So let's work out what are we trying to actually find. So we're trying to find ADC. So go with middle letter D, join it up to A, which is that line, and C, which is that line. So it's this angle that we're trying to find. Now, quite often there are a couple of different ways that you can do this. I'm going to use first of all, the arrow like that, okay? And if I know the angle here at the centre is 168, well, I know the one at the centre is double the one at the circumference here. So I'm going to half that to get 84 for that angle here. So far I'm going to write, I'm sure if you wrote angle B that would be fine, but I'm going to write it properly. So it's the angle at B between A and C, isn't it? So I need to put between A and C. So angle ABC is 84 degrees this is a 4-mark question, so you need to make sure you write everything out properly. So 4 marks. So it's 84 degrees because the angle at the centre is double the one at the circumference. Okay, and now I know this one, and you'll remember me saying a minute ago that actually if I know this one and this one should be adding up to 180 degrees, because remember we've got 1, 2, 3, 4, it's a cyclic quadrilateral, all 4 points are on the edge, so the opposite angle should be adding up to 180. So angle ADC, which is the one that we were trying to find, this one here, angle ADC is 180 minus 84, which is going to be 96 degrees. And again, because opposite angles, I'm just going to put op angles. Right, again, to save time on the video, I'm just going to write CQ, but you would need to write cyclic quadrilateral add up to 180 degrees. Okay, so the answer, yes, is 96, but if it says give reasons, you're probably only going to get 1 mark if all you do is put in that. Okay, you need to make sure that you are writing down all those wordy theorems. Right, so let's have a look at another one. I don't know that these are in any particular order of difficulty, so this may be one of the harder ones I've now picked out. So for this one here, show that angle Y is 35. So again, let's think about some things before I worry too much about that. Let's think, well, 1, 2, 3, 4. I've got a cyclic quadrilateral in this question, so I know that this one and this one are going to add up to 180. I've got a centre here marked on, so that's a radius and that's a radius, so I've got an isosceles triangle. And I've also got the arrow shape here. So this angle here is going to be double this one, and chances are it's going to be exactly those things that are going to help us solve this question. So first of all, I'm going to use the fact that 1, 2, 3, 4 cyclic quadrilateral, this one and all of this here adds up to 180. Now I've just kind of gone over the bit, only that little bit there is 33. So I'm going to get my calculator and I'm going to do 180 minus 112, which is 68. So I know that the whole thing here must be 68, and I'm going to take off the 33, which is 35. So this angle here must be 35 degrees. Now I've got an isosceles triangle because that's a radius and that's a radius. So these two angles here are going to be exactly the same, and so Y is going to be 35. Now again, give reasons for each stage of your working. So what did we do? We said A, B, C, D is a cyclic quadrilateral. Opposite angles add to 180. So 180 minus 112, we said that that was 68 degrees. And then 68 take away 33 was 35 degrees. That's some of it, and now we need to say that we use the isosceles triangle. So it's triangle ABC, or you could say CAB, COB if you wanted to. So it doesn't really matter for a triangle which ones you do it in which order. So ACB is isosceles, so therefore Y is also 35 degrees. Right, working out angle Z is the next part. So working out angle Z, well, remember we said we've got the arrow shape here. So if I can work out this one, then I know I can half it to get Z up here. So I said that this one here is going to be 35. Well, that's going to make, remember this is a triangle, so I've got 70 so far. All three angles should be adding up to 180. So if these two make 70, this one's going to be 110. And now the angle at the centre is always double the one here when you've got that kind of arrow shaped look here. So I'm just going to half that to get this angle here. So half of 110 will be 55. Right, so again, it's a 3 mark questions time. So it's going to be 1 mark for this. They want your reasons. So we use the fact angles in a triangle add to 180. So it'll be angle BOC, because I want the middle letter. It's the one at O, but it's joined between B and C. So I've put those letters either side of O. So angle BOC is 110 degrees. And now Z is 55 degrees because the angle at the centre is double the one at the circumference. Don't know why I didn't use those dotted lines, but never mind. Right, let's do, I think I've got a few more to do. So this one here. So things, again, let's not worry about the question right now. Let's just have a good look at this. What can we work out? Well, I've got 1, 2, 3, 4. There's a cyclic quadrilateral in this question. So these two will add up to 180. All of this and all of this will add up to 180. Not sure that particularly helps at the moment, but it's something to bear in mind. No centre, so no radius to mark, or like there's no isosceles triangles that I can see, no diameter. However, I have got a tangent here. And the 72 goes between the tangent and this chord here, doesn't it? DB. So this angle here is the same. If I join up the ends of the chord up here, the 72 is going to be the same as this one up here. And that is the alternate segment theorem. So that is actually the first question. Work out angle X. So it would be 72 degrees because of the alternate segment theorem. Which is probably why it says only 2 marks. 1 for 72, 1 for alternate segment theorem. Right, working out angle Y. Well, do you remember me saying a minute ago we've got 1, 2, 3, 4 points on the edge. This is a cyclic quadrilateral, so these should be adding up to 180 degrees. So it's going to be 180 to take away 72, which is 108. But the reason is because opposite angles in a cyclic quadrilateral, please make sure you write it out properly. I'm just saving time on the video. Add up to 180 degrees. So really, circle theorems, like I say, there's sometimes more than one way to do it. Make sure you have a really good look at that picture before you even worry about what the question is. Look out for 4 points on the edge. Look out for centres. See if there's any isosceles triangles. Look out if the centre is being marked on like this. There could easily be a diameter, in which case the opposite angle, remember, like this, would be 90 degrees. Look out for like a radius and a tangent because they make 90 degrees. It's just having a good look, and the more you do of these questions, the more you will spot these things and they will become a lot easier.